Okay, in this section of 3.3, we're going to be solving equations with variables on both sides, okay? So you need to remember that you have variables on both sides, and if they're on both sides of the equal sign, it's like there's that big bar up there, and you cannot be combining them together. You cannot put 5n and 9n together to make 14n. They're on opposite sides. In order to fix that problem, you need to do the opposite of what is happening. Now, you need to either get rid of 5n or get rid of 9n. I always get rid of the smaller guy. So that kind of helps me avoid negatives. You can't always avoid negatives, but in general, that's pretty helpful usually. It's a good rule. So I'm going to subtract 5n to both sides. Now I can write it underneath, minus 5n here under the n's, or I can write it in row format, and you know they like that here. So I'm going to write minus 5n. If you don't like minus 5n, you can say adding negative 5n. So I'm going to subtract 5n to both sides. So a positive 5n and a negative 5n, they cancel, and we're left with negative 7, and that's what's rewritten there. Over here, I have a 9n minus 5n is 4n, and the plus 21 gets rewritten. And now what do we have? A two-step equation. You got it. So we're going to subtract 21 from both sides. Here's my original 4n plus 21 minus 21. Whatever I do to one side, I do to the other. And so if you don't like minus 21, you're going to make it adding the opposite. So a negative 7 and a negative 21 is a negative 28. These canceled, and we're left with 4n. Here's my lazy step. I'm going to just divide by 4 like this. N equals negative 7. We divided both sides by 4. The solution is negative 7. We are going to check this over here on the side. Let's check it right now. So we have 5 times n, which we think is negative 7, minus 7 equals, with your question mark, 9 times negative 7 plus 21. Okay, so we're going to multiply first. So it's negative 35 minus 7 equals, and then 9 times negative 7 is negative 63, and rewrite the plus 21. And then if you don't like that minus 7, make it adding the opposite. Add them together since they're both negative, and that's a negative 42. And then 63 minus 21, yep, it's 42, and there's more negatives, so it's negative 42. So it works. Great job. Okay, so I want you to practice one of these before we do any other types of problems. So please flip to the next page, and you're going to do number 1 over here. So pause the video, do number 1 on your own, and come back and see how you did. Okay, notice in the directions it said to check your solution. If you didn't, pause it and check your solution. It does work out. It's n equals negative 13. I subtracted both sides by 3n first. However, if you got rid of the 5n first, you still could have gotten the same solution. Even if you got rid of one of the constants first, you could have gotten the same solution. It just gets a little trickier that way, because then it's not your normal two-step work. So see Mrs. Wyman if you have a question about that. Otherwise, go back to the first page of this note, and we're going to do another type of problem where there were variables on both sides, but there is, you got it, distributive property. So let's distribute first. So we have 6x plus 3 equaling 6x. Now let's think about that. We're going to multiply this side by 6, so let's pick a number for x, any number. Multiply by 6 and then add 3. But on this side, we're going to multiply it by 6, but not add 3. Can that ever happen? No, it can never happen. So this is a very unique problem. This one doesn't have a solution. Now, if you're not understanding that, I'm going to take this guy one more step over here. 6x plus 3 equals 6x. Okay? So we've learned if there's variables on both sides, you get rid of one of the variable terms. So I'm going to subtract 6x by getting rid of the variable term here. That's 0. And what's 6x minus 6x? 0. Can 3 equal 0? No, 3 doesn't equal 0. So this is not true. It's a not true statement. We say 3 cannot equal 0. Since the statement is not true, the reason why is because 6x can't be equal to 3 more than itself. Can't be equal to 3 more then itself. I can't write with these markers, very teeny. Okay, the equation has no solution. So that is the answer. So as soon as you get this, you could have said no solution. No solution. And if you didn't recognize it there, you would have recognized it here, and then you would have said no solution. So as soon as you recognize it's no solution, you're good. Okay? So since it has no solution, basically, as you check, you can continue solving the equation they're talking about here. That's exactly what I did over there. So we don't even need to worry about that. We're just going to say it has no solution. Okay? 3 doesn't equal 0 is not true, so the equation has no solution. We don't need to go any farther in the notes there. They're just talking about the same thing that I just did. All right, let's look at example 3. A unique thing is going to happen in example 3. We have the distributive property again, so let's distribute our 4x. And we get 4x plus 8 equals 4x plus 8. It's identical on both sides. So what does that mean? That means you can put any number in for x, and guess what? It's always going to be true, no matter what. Okay? We could get rid of the x terms if you didn't recognize that. 4x plus 8 equals 4x plus 8. Subtract your 4x to both sides, and 8 equals 8. Of course it does. It's always true. So that's what that means here when we say 4x plus 8 equals 4x plus 8. It means that every number is a solution. So the equation has all real numbers as a solution. So we would say all real numbers are a solution. The equation has all real numbers as a solution. And you don't have to write the whole sentence out now. You can just say all real numbers. Everything is going to work. Okay, so what I'm going to tell you is you've got 3 practice problems to do. And some are going to have a solution, some aren't going to have a solution, and some are going to have all real numbers. So go ahead, pause the video, do your good work, and then come back and see how you did. All right, good work. Let's see how you did. So you distributed over here, and the first thing that happened is you got an untrue statement. So right from there, you could have said no solution. If you didn't recognize that, you would have subtracted 12x. 0 does not equal 4. You have your does not equal sign, and then you would say there are no solutions. In number 3, you're going to distribute, and as soon as you do that, you should have recognized you have an identical statement on each side. Each expression is the same. If you didn't, you would have subtracted 6n, and then you would have gotten 12 equals 12, which is also a true statement. So then we say all real numbers. And you'll notice there's not a check when there's no solutions or all real numbers. Certainly you could plug things in to prove that nothing worked here and that everything worked there, but other than that, there's not just one check that's true. In this guy, I'm going to add 2x to both sides to get rid of the negative 2x on the right. You could have done other steps first and still gotten the same solution. There's my 2-step work. X equals negative 5. And here's my check to prove it. Both sides end up being negative 3. Solve the left and the right separately, and then prove that they're the same number. Okay, see Mrs. Wyman, if you have a question. Otherwise, you're on to your last type of problem. And this is a perimeter problem with a square. So what is perimeter? Remind me. Yep, it's the distance around. And what do you know about a square? About their sides. All sides of a square are equal. So this is saying find the perimeter of the square. But I can't find the perimeter when I don't know what x is. They need to tell me the sides are like 2 or 17 or something. So I can't do that. But what I can do is use my brain and decide, hey, if this is a square, I know this side is the same length as this side. So 3x is the same as x plus 6. Oh, well now I know how to solve that problem, right? So I'm going to subtract x or 1x to each side, and I get 2x equals 6. Showing my work here, I subtracted an x or a 1x. Divide by 2, x equals 3. Now I'm not done. It didn't say find x. It said find the perimeter. So I need to take that and plug it into one of these two guys. It doesn't matter which one because it's going to be the same length. If I plug 3 in for x to either one, let's say I plug it into this 3x. 3x is now 3 times 3, which is 9. Don't believe me that it would have worked? What if I had plugged it in here? 3 plus 6 equals 9, right? So the square has a distance of 9 on each side. And to find the perimeter of a square, it's P equals 4S. Okay? So we're multiplying the length of one side by 4. So it becomes P equals 4 times one side is 9, which means the entire perimeter is 36 units. And I would add in their inches or feet or whatever, but they didn't give me a unit yet, so I can't do that. Okay, so it's your turn. Last problem there. Pause. Do a good job. Come back and see how you did. All right, so that was 16 units. I ended up getting 4 for my x, and then I plugged it in to, oops, just kidding. It's not 4x. Let's back up. See what I did there? I used x, and I plugged x in. That was a big old mistake. X is 4, Mrs. Wyman, so now you have to plug it into one of the sides. So 5 times 4 is 20. So each side is 20, not 4. Over here I would have gotten 3 times 4 is 12, plus 8 is also 20. So P equals 4S now, which means it's 4 times 20. So my perimeter is 80 units. Whew, good thing I caught it. All right. See, everybody makes mistakes. All right, so you are on to your assignment. Good work, guys. Good work.